so-called gravitational lensing is fictional. It's inexplicable in the heliocentric model. It is simply glass, the glass of the heavens. The refraction caused by the heat of the sun, bulging out the glass that is covering the sun, and displacing the apparent position of the stars. What we're looking at, obviously, is a moon in front of the sun with background stars. Now, if I go to my top view here, go to wireframe mode. I'm going to show you what's going on. Okay. Concave Earth, glass skies. You'll notice this yellow glass sphere is surrounding the celestial sphere, the inner sphere there, and then we have the moon sphere, and then we have this the largest of the glass spheres. They all have different indices of refraction. At least one has a negative index of refraction. And you'll see this yellow glass sphere. Now imagine if my camera was, it's down at the bottom. And I got a little sun. It's right over here. There's my sun. It's behind the sun glass sphere. And then the moon is right in front of it. The moon is right below it. There's the moon, okay? So the camera's pointing straight at the sun-moon alignment. And what is going on? I was doing a little bit of fiddling around with eclipses in 3D. And what is happening is that because the sun is it's hot, it's going to generate heat and it's going to create thermal expansion of the glass sphere that it's behind. And so it's going to create a bulging. And so let's get that bulging. Right now I have the bulge on the opposite side. You see at the top there's a little bulge. And so if I turn that around, rotate it, so it's directly in front of the sun. Now the bulge is right in front of the sun over here. And now we can look through with our camera with the refraction turned on. There's a refraction. Now it's off. Now it's on. So we're always looking at the sun and the moon through glass with refraction. That bulge is actually going to displace the background stars, and that's exactly what they observed, Eddington and Einstein, is that the background stars were displaced as if looking through a glass. Wine glass, yeah, that's the ticket. So what I'm going to do is I'm going to rotate that glass sphere so it's behind again, so we're not looking through the bulge, and you'll see the difference. I'm going to just toggle 180 degrees like that, and then I'll go back to 0. You see the displacement of the stars? That's all that's happening. Thermal expansion is happening. When you look at a nebula, let's use a regular atmospheric cloud for a reference object. Which dimension seems more believable? 50 million light years across, or about the size of a cloud? Nebula means cloud. The truth is hidden in plain sight. The stars are close. They have to be close. The concept of light year is fiction. They have to conjure up prodigious distances in order for their model to work. But common sense tells you it cannot work. We see the stars. The stars are close, very close. The stars are small, very small. The stars are behind glass. The glass has a bumpy surface to it, damaged after the flood. Glass causes chromatic aberration. The different fringing of the bumpy surface causes different redshift readings. Redshift of galaxies is simply chromatic aberration of the glass encompassing the stars. The spiral pattern of galaxies are simply indications of drainage. The celestial sphere contained water. The water came pouring out when the windows of heaven were opened. Stars are formed by a process of sonoluminescence, extremely hot sound bubbles. Because they are bubbles, there is not much mass detected in stars, but rather mass is detected in the area surrounding the stars, otherwise known as dark matter. Dark matter is simply dark waters or liquids as recorded in the scriptures and confirmed in recent scientific studies. During the time of the flood, the stars clustered together and they melted holes through the glass firmament. Water and sand came pouring down to earth. Because of the frigid temperatures, the windows of heaven congealed back together, leaving a spiral remnant of the drainage. Hidden in plain sight, the glass is detected by comets. In photography, a glass anomaly is created by the lens called coma aberration, named after a comet. When we view a comet in the sky, it is because the sunlight is hitting the comet at an oblique angle as it is immersed in the plasma field above the glass. There is birefringence to the glass, which splits the tail in two. Sagittal astigmatism, tangential astigmatism, coma aberration are all clear indications that there is glass in the sky, hidden in plain sight. The curvature of the comet's tail is a clear indication that light is bending. It should not be any surprise to anyone that they had found Star Trek-like invisible shields thousands of miles above Earth, where they say it's almost like these electrons are running into a glass wall in space. But there is most likely at least 3 concentric spheres of glass in the Earth, apart from the main celestial sphere. This is detected easily by viewing the 22nd degree halo and the 46th degree halo, and understanding that there is a much lower glass at approximately 100 kilometers. Hidden in plain sight once again, we can understand that there is glass at 100 kilometers based upon upper atmospheric lightning hitting a ceiling at 100 kilometers. We also can understand that auroras bottom out at 100 kilometers. Radio wave propagation reflects off the ionosphere at 100 kilometers. The height of the Schumann resonance is at 100 kilometers. Scientists say that sporadic meteoroids are bouncing off the atmosphere, the sporadic E layer of the ionosphere, the neutral density layer of the ionosphere, like bugs hitting a windshield at 100 kilometers. Coincidence?
It's plowing up this debris, just like a bug on a windshield effect. Just like a bug on a windshield effect.
Just like a bug on a windshield effect.
But to a child, a simple rainbow will suffice in having them understand that there is glass above. As the sunlight disperses through the glass, it gets projected onto reflective water droplets. The water droplets are not the source of the rainbow, but merely the reflective canvas of the already glass-dispersed light.